Hello all of you. My name is Vagmari Tejasvi Ramesh. I am a junior college teacher at Rayat Shikshan Samstha's Karmavir Bhavrao Patil Junior College, Vinsur, Taluka Nifad, District Nasik. Today I am going to discuss one topic from the chapter Probability Distribution, which chapter is from 12th Science book of Mathematics Part 2. In that, first topic is probability distribution of discrete random variables. For this probability distribution of discrete random variable, we considering one example, and after that we will go to our definition. First, let us consider the experiment of throwing two dice and nothing the numbers on the uppermost faces of the two dice. Okay, means if we going to perform one experiment of throwing two dice at a time, then we consider the numbers on the uppermost surface or uppermost faces of the two dice. Then all possible outcome will be, if we throw one dice and we note down that one of the two dice we get number 1 and other dice also gives number 1, then we call it as order pair 1 1. Like as we perform it so many times, then all possible outcomes will be like as order pair 1 1, order pair 1 2, order pair 1 3, like that order pair 6 6. And if we put these all possible outcome in one set, and we call it as a sample space. Means all possible outcome will be in one set. That set is called sample space, and number of element in sample space S is equal to 36. N of S means number of element in sample space is equal to 36. Let X denote the sum of two numbers and any single throw. Then 2 3 up to 12 is the set of possible values of X. Means if we throw a dice or two dice at a time, then we get either 1 1, 1 2, and we add it as 1 plus 1 is equal to 2. Like this we get all addition like 2 up to 12. All numbers will be 2 3 4 5 like up to 12. And that set is set of possible values of X. Further, if we consider capital X is equal to 2, means what? Capital X means what? Number of sum of two numbers in a single throw. Means addition will be 2. Then we will get only one possible outcome, that is we getting order pair 1 1. Like that X is equal to 3 means what? Addition will be 3. For this we get two outcomes, like we get 1 2 order pair and order pair 2 1, like this, and so on. We can perform for X is equal to 12. For X is equal to 12, again we get only one possible outcome. Okay, possible outcome will be order pair 6 6, means 6 plus 6 is equal to 12. Okay, like that As the result, each of these 36 possible outcomes has the same probability. Means each probability, each number of x is having same probability as probability will be 1 by 36. Okay, this leads to following result. P of x is equal to 2 means probability when x is equal to 2 is equal to P of order pair 1 1. Okay, P of order pair 1 1, which is equal to 1 by 36. Means what? Probability of getting 1 1 is equal to 1 by 36. Now probability for x is equal to 3 is equal to probability of getting order pair 1 2 and 2 1. That is equal to, it will give two possible outcome. Therefore we will take it as 2 by 36. We will take it as 2 by 36. Therefore we will performing this as so on. We will get in, see this table. Then from this table we can observe that if we for different values of x we get different values of p of x. P of x means probability of x. Therefore for 2 we get 1 by 36 probability, for 3 is 2 by 36, 4 is 3 by 36, 5 is 4 by 36, 6 is 5 by 36, 7 is 6 by 36. For 8 means addition will be 8. There will be 5 possible outcome out of 36. Therefore 5 by 36, 9 4 36, 4 by 36, 10 for 10 is 3 by 36, 11 is 2 by 36, for 12 is 1 by 36. This represent probability distribution of random variable x. Okay, from this we can understand what is the meaning of that probability distribution. Okay, next we go for definition of that probability distribution of discrete random variable. Probability distribution of discrete random variable x is defined by the following system of the numbers. Let the possible values of x be x1, x2, x3 and corresponding probabilities be denoted as p1, p2, p3 and so on, where pi is equal to probability of capital X is equal to small xi for I is equal to 1, 2, 3. It gives xi and if we write it as in a table form, we will get the values of xi and probability of x is equal to xi when x is equal, capital X is equal to xi, where I is 1, 2, 3 and so on. Means for each xi there will be a probability which is denoted by pi. Okay, from this we can say for every xi there will be only one probability and that will be denoted by pi. Means x1, for x1 is there will be p1, for x2 is there will be p2 and so on. Next, probability mass function definition. Let the possible values of discrete random variable x be denoted by x1, x2, x3 and so on with corresponding probabilities. Pi is equal to p is equal to x is equal to xi. Probability of x, where x is equal to xi and I is equal to 1 to up to so on. If there is a function f such that pi is equal to probability of x is equal to xi, which is equal to function of xi for all possible values of x, then f is called probability mass function of x. There is a difference between probability distribution of discrete random variable and probability mass function is same as for every xi there is a probability of that number. Means for first x1 there will be p1, but if we consider in this for probability mass function there is a one function which denoting the probability of that particular experiment, and for all possible values of x then f for that all possible values of x there is a function is called probability mass function of x. For this we consider one example. For example, consider the experiment of tossing a coin four times and defining the random variable x as the number of head in 4 tosses. The possible values of capital X are 0, 1, 2, 3, 4, and probability distribution of x is given by the following table. Means what? Capital X is what? The number of heads in 4 tosses. Means one coin, if we consider one coin and we tossing it for 4 times, then it will give either 0 head or 1 head or 2 head or 3 head or 4 head. Means capital X is equal to 0, 1, 2, 3, 4, and probability distribution of capital X is given by the following table. Means for 4 times if we toss that coin, then it will be 16 possibilities. If we get 0 probability, 0 on that coin, 0 means what? We get tail, not a head. That means our capital X is 0. Therefore, only one possibility. Therefore, we get 1 by 16 that probability. For getting 1 head on 4 toss, we get probability of 1 by 4. For 2, there will be 3 possible outcome out of 8. For getting 3 heads, we get 1 by 4 probability, and getting 4 head 1 by 16 probability. Okay, this is the example for probability mass function. Okay, thank you. It will be only this one. Thank you so much.